I am Madan Kumar Radhakrishnan. I would like to give some introductions about me. First of all, I would like to share my studies of UG and PG. I was studying in St. Joseph's College, Trichy, okay, Bharatidasan Universities, and BL. I was studying in Kalakurchi, Kalevani Education of Colleges. Okay. And then I started my career in Valamal, Chennai, Pancheti. Okay, Pancheti is Poneri. I was working 2 years, so 2014 to 2016, and I came back to my native, AKT. And then 2017 to 2018, I was working in AKT, which is located in Kalakurchi. Okay, you know that. And then 2017 to 2020, I was working in Sri Shanta Vidyalaya Metric Higher Secondary School, which is located in Thiruvannamalai. Okay, I was working. I have got some more experience right there. For example, in 2019, one student, she is really bright student, Nivedita. Okay, she is a Nivedita. She's got a 98 mark in my subject. Okay, I was trying to give sentence. I like to produce a sentence. I gave more and more effort to her, and she got 98 mark. She lost mark one, 3 mark. Another 1 mark is received from 1 mark. Okay, these 2 marks are gone. That's why she got only a 98 mark. Okay. Now, I like to. This is my profile and careers. Okay, I like to give the introductions about carbon and its compounds. Okay, it is basically very interesting topic because the carbon, everything is carbon. Okay, wherever you can go, the carbon should roles carbon role should be there. For example, suppose we want to come from home. Okay, we are using the bike or cars, whatever it may be. Some vehicles are using, which is also fuel. Fuel is containing the carbons, okay, carbon molecules, okay, and then we are wearing clothes, very essential to us. We are wearing clothes is containing also carbons. Now, next, suppose we are taking food materials, whatever it may be, what you like. Suppose rice, whatever it may be, it is also carbon contains. Okay. Now, the carbon is most important to the human being. It has a different one. It is which is more and more different things we have the topics. First of all, I gave an animated video to attach this video. That video, I'm making something, whatever possible. I'm making differently. What happened? I explained much more. Suppose in the classrooms, it is possible to explain much more, but in the small online classes, it is unable to explain much more. Carbon, suppose carbon, there is the introductions about the carbon, and then define the altropies. Carbon altropies will be there, and then carbon covalent. Last, covalent characters. Okay, covalent character I explained that video, which is that which needed to know what is the covalent bond, what is the ionic bond, that is the relative that one. Okay, I will give that animated video. You can see. Suppose is there any mistake, you can tell. I will change the mistakes. Carbon and its compounds. First topic, Forms of carbon. Carbon, how it is formed? In various types we have to see the carbons. Okay. For example, we have to take pencil. It is made up of only by the carbon, graphite and wood. Carbon present in our daily life. First one is cloth, food items, fuel, human body and animal's body. Okay. Sixth most abundant elements in the earth crust. Okay, universal. Sixth most abundant element of carbon will be there. Today objectives: explain the significations of carbon in our daily life. List example of occurrence of the carbon in nature. Define allotropies. Describe the different allotropic forms of carbons we can see today. First, free and combined state. All metals and non-metals, it may be free and combined state will be available. First one, what is the free state? Another combined state. First we should see the what is the free state. Free state means the element, which element, whatever it may, whatever it elements, it is free in nature. That element should not combine to other elements. Okay, we can see the universe should be made by the elements. Okay, whatever it may be you are touching, whatever it else, it should be the one of the elements. Okay, suppose free state, for example I will come to the carbon. Free state carbon should be the combining with another carbon only. You should not combine with other elements. Okay, that is called free state. Suppose combined state, the carbon should be combined with any other elements. Suppose carbon is combined with hydrogen, carbon is combined with oxygen, it is called combined state. Okay, combined state. Now free state contains diamond, graphite, fluorine and coal. Okay, these are free states. Combined state contains gas. Gas in sense carbon dioxide, carbon monoxide, these are gases is available in our atmosphere. Okay, liquid. Liquid in sense uh, petroleum. Okay, petroleum product, which is the we are using the fuels. Okay, solid in sense limestone. Okay, calcium carbonate. Okay, calcium carbonate, we are using the limestones. So limestones are present in earth crust in the combined state of carbons. Okay, now allotropies. What is the allotropy? First of all, we should know about the allotropies. What is meant by allotropy? Allotropy of it is not only carbon. Okay, the carbon and suppose sulfur, phosphorus. It's containing the allotropies forms. Okay, what is meant by of allotropy? Carbon. Suppose I am taking the carbon. Carbon is combined with another carbon. Okay, combined with another carbon, the form of something uh, uh, is like say 4 carbons and 3 carbons and 60 carbons, like that. The carbons are combined with another carbon, is called also allotropy. Now we can see the allotropy properties of elements allows to exist some more than one form. Suppose carbon only one form, then means no, carbons is a diamond, graphite, fluorine, like that the formations are allotropies. Allotropies are two types. Okay, one is the crystalline allotropy, another the amorphous allotropies. Okay, now crystalline allotropies: diamond, graphite, fluorine. Okay, and amorphous allotropies coal, coke, wood, charcoal. Okay, these are amorphous allotropies. Now like to see the what is the crystalline allotropies. Okay, how it is bonding. Now diamond it is a most expensive nonmetals. Okay, diamond is bonding with carbon is bonding with another carbon. For examples, it's a three-dimensional structure. Rigid, it is a very highly rigid, hard, and break. Okay, it is a bad conductor and electricity. So it is cannot be conduct the electricity and the heat. Okay, bad conductors and the graphite. Where its graphite is present, we are using pencil. It contains the graphite layer. Okay. Now, it's the hexagonal structures. Graphite contains hexagonal ring structure, joint form of the layer. You can see the video. Joint forming. Okay, joint forming like that. Hexagonal structures is available. Okay. Third, carbon bonding with three carbons. Another carbons it could be free. It is a good conductor and electricity because one more free electron is present. Next one is the fluorine. Okay, fluorine. Fluorine is a it is discovered Robert Cord and Cord Ratio and Richard families 1985 they started the research on the fluorines. They got Nobel Prize 1996 for this reason. The fluorines molecules consist of 16 carbon atoms around in the pentagons and the hexagons. These structures are like a football structures. Okay, now Buckminster's fluorines. It is also one of the structure of fluorines for examples. Okay. Now we can see the carbon by cloths, tables, fruits and vegetables are human being. It's all of the carbons. Okay. Now next objective types is list of the properties of covalent compound. Explain the reason for each properties of covalent compounds. First of all, I would like to see the what is the covalent compounds. Okay, covalent compounds. There is a different types of bonding is available. First one is the covalent bond. Another one is the ionic bond. Okay, covalent bond is sharing of electron between the atoms between the elements are sharing of electrons. Okay, sharing of electrons, mutual sharing of electrons, that's why it is called covalent bond. Okay, ionic bond it is donating and accepting whatever it may be, it is happening the donating or accepting. Okay, now we like to see the covalent compounds. Okay, now we are taking the examples of chloroform. We are taking the example of chloroform. The chloroform low melting point, covalent compounds having low melting point and a boiling point, very low melting point. Okay, chloroform very low melting point and a boiling point. For example, chloroform 60 degrees Celsius it is the boiling point. Okay, now like to see the carbon tetrachloride conductors of non-conductor of electricity. Okay, why it is non-conductor of electricity? Because of absence of ions. Because of absence of ions, that's why it is the non-conductor. Valency of carbon. Okay, carbon valency, first carbon atomic number is 6. Carbon atomic number is 6. Now electronic configuration of carbon. Oh, K shell. Suppose K shell, K, L, M, N shells are there. First K shell has 2 electrons and L shells are 4 electrons. Which is the outermost shell? L shell is the outermost shell. We know how much electron is present in the outermost shell? 4. Okay, that is the valency of electron. That is the valency. 4 electrons is present in the outermost. That is the valency of carbon. Okay, which is, for example, Suppose the carbon wants to donate 4 electrons, it will become the noble gas configurations. Okay, noble gas configurations. Suppose it donates the 4 electron, what happen? It will become C4 plus. Okay, C plus 4 ion. It will come the cation. C plus 4 the ions. Okay. Suppose it is lost 4 electrons. Suppose it is lost 4 electrons from their outermost shell of the carbon. It will be unstable because the nucleus contains 6 proton. It unable to hold that. Okay, it is unable to living that. That's why it is unstable. Suppose it is getting 4 electron. Suppose getting 4 electron, it's become minus 4 ion, anion. It's become the anion. The anion also, the nucleus unable to hold the 4 electron, extra 4 electrons. That's why the nucleus become unstable. So these four types unable to possibles to leaving the carbon atoms. So it is preferable to only the sharing of electrons, only the sharing of electrons. That's why it is ready to share the electrons to the neighbor atoms, ready to share that to the neighbor atoms. For example, hydrogen, there is 4 hydrogen is available, 4 hydrogens giving one, sharing the 1 electron to the carbon, and hydrogen and oxygen are sharing the 1 electrons to the carbon. It is the stability in carbons. It is the stability in carbons and reach the noble gas configuration.